Alright, so let's see if it works. If not, I'm sure somebody else already did it, right? Alright, C. We're going to talk about some structures of C. So if you use Visual Studio, C or any compiler will have a set of keywords that are reserved, that you can't use it for something else. For instance, the word if. If is an if statement. You can't declare a variable called if. Same thing with any data type. We're going to talk about data types: int, longs, chars, bits. One of the things C uses is a pound sign. You can call it a directive, a macro. So if I call it a directive, I can put a reserved word after. I can use the keyword include. Include says, get this other file that is going to have some functions built in that I need to run the program. And we can add our own, we can use the ones built in. And there are two ways to include a file. One will be using the greater than sign or less than, and then and close it, or we use double quotes. Doesn't matter. Well, it does matter actually. If you use the less than greater than sign, it says this file, the compiler will find it in the directory where all the common files are. So if you were to go to C, Windows, common files, program files, common files, and Visual Studio, it will find it there. If you use double quotes, it'll say this file is located in the same directory as this program. Then Java and C and C++ use delimiters to indicate a block where it begins and where it ends. And the delimiters are just curly brackets. So I can have a curly bracket, I can have some code, and I have to close it somewhere. I can open another one below, and then more code, and close it. I cannot open one here and close it here. They can't overlap. Right? So this you can't do. You have to open and close it. You can open another one inside, it's fine. It's like, if you think of it like boxes, you can put smaller boxes inside the box, but you can't overlap the boxes. Also, we need to have a point of entrance in our program. And the compiler is going to look for a function called main function. And if you use Borland C or just Notepad or Eclipse, you will find it like this. It will say int, it will say main, and I'll have the open and curly brackets. Visual Studio uses _t main, and it has some parameters inside the parentheses, and I'll explain to you what those are. It doesn't matter. If you use Visual Studio, it automatically adds it for you, and I'll show you. So let's assume we have a 32-bit operating system. that means the word size of that operating system is 32 bits. Every instruction is 32 bits, every address it allocates is 32 bits. It won't be any bigger or smaller. You might have multiple 32 bits. So, your RAM is just a contiguous amount of memory. It's just like a big box. And the operating system is in charge of breaking it down into multiple sections, depends on the program, and each program has an allocated space in memory. So, the RAM, when you buy the RAM, doesn't know if you're going to have a 32, 64-bit or even a 128-bit system. So it's just a contiguous amount, and it starts at the address 0 and it goes all the way to the address that operating system supports. For instance, if you have a 32-bit operating system, that means the max number of addresses you could have is 2 through 32. So if you do that in your computer, it'll come up to 4 billion something. So that's why a 32-bit operating system, the maximum it could have is 4 gigabytes. So you say, oh, I need more RAM, and you still have a 32-bit. It doesn't matter if you put more. You can't access it because the max is 2 through 32. So if you do, let me see. 32 is 4294967 296. So that's the max RAM you could have. We said 4 gigabytes because we rounded. So you say, oh, I'm going to have a 64-bit. I'm going to upgrade my operating system. Okay, so now you could address more. To the 64 is 1.84 times 10 to the 19. So it's a very large number. So you can have more memory addresses. But guess what you just did? If you leave your computer with 4 gigabytes, you just cut your memory in half. Because each address now is 64-bit. Every instruction is 64-bit. So if you want to have the same performance, you will need to double your RAM to be 8 gigabytes. But the beauty is you're not limited to 8 gigabytes. You can add, I think my highest server is 256 gigs. So it has a lot of RAM. Make sense? So, to indicate addresses, you'll see in textbooks they use the 0x to indicate that's an address. So, for example, I'm going to start at 1000, and then I'm going to increment in 32 bits. When you look at this in the computer, it's not going to be decimal, it's going to be in hexadecimal, but the value is the same. And so on. So, when the program starts, your operating system is going to give that program a small amount of memory. It's going to have a minimum. Honestly, I don't know in Windows 10 what it is. It used to be 1 megabyte since Windows XP when I went to school. So, the operating system has this RAM allocated to your program. We're going to talk a little bit about variable declarations, variable types. So let's erase this. So a variable is like math. It's just a placeholder. So when you declare a variable, it's just saying, can you give me some RAM to put some values in that RAM? And your operating system is going to give you whatever space you requested. Unless it gives you an error, it says out of memory or something, but I get those sometimes. Depends what I got running. So the way you declare a variable, the syntax is variable type and for now we're gonna use an integer, which is a 32-bit. We will use a long, which is a 64-bit. We could use a character, which is 8 bits. We could use a boolean, which is 1 bit. We could use, there's a few others, but let's work on this today. 4 more. So after you select the variable type, you gotta give it a name. And the variable name as a first you can't use a reserved word like one of this or include. But the variable name has these rules. It says the first character of the name has to be a letter or underscore. So you cannot start a variable with a number. So it has to be underscore or a letter followed, if you need, followed by letters, numbers, or underscores only. You cannot have spaces, you cannot have dot, commas, hashtags, nothing. It's alphanumeric and underscores. So first character is letter or underscore followed by letters, numbers, or underscore. So technically you could have a variable name like that, but that will not be very useful for you later. So what we do is not a rule, it's a habit, I guess. We declare a variable, start the names with the first letter of the type. So if it's an integer, we start with an I, if it's a long, we start with an L, and so on. So when you have a long code, you could say, oh, start with an I, that's an integer. I don't have to worry about it. So at the end of the sentence, you need to have an end of statement character, which is simply a semicolon. So the syntax is type, name, semicolon. Bless you. Questions?
Yeah, it's a variable. The letters, numbers, or underscores with the semicolon is the variable name.
No, that's a rule. Bless you.
Oh.
So, for instance, let me erase this then. Let's say I have a variable for age, I will just call it age. That's it. So what the operating system is going to do, this is an integer. It's 32 bits. It's going to go find the next chunk of memory that will fit this variable. So it'll say, oh, you need an int, so we're going to put IH here. So basically IH goes in address 1000. So what the operating system is going to do when it runs, it's not going to care what you name your variable. It's going to replace the name with the address. So it's going to use the address. Make sense?
IH means integer, variable integer, and age.
It's just a name I gave it.
And the compiler brings the address with the information in that address?
No, it replaces the name of the variable with the address. What you do with the address is up to you.
Oh.
So, if I say long, I don't know, we can use L, and I'm going to use student ID, for instance. And the student ID is a long. That means it's going to need 64 bits. So it's going to use 2 blocks, right? And this is going to be student ID. And the operating system is going to replace the variable name with the beginning address where it was allocated. So it's going to do this when it runs. Character is 8 bits. So I can't allocate 8 bits. I can only allocate 32 at a time. So it'll be nice if I declare 4 characters at once. Then I don't waste anything. But if I don't, if I only allocate 1, for instance, I say grade, that's where I'm going to hold your letter grade. That allocates 8 bits. So it's going to do this. It's going to allocate here 8 bits, and this becomes wasted. So now I have C grade here, which is 8 bits, and this is going to be replaced by the address where it begins. Yes?
For the long 64 bits, after the replacement, it's only 0, 1, 3, 2, so it's only the 64, the 2 blocks is replaced by just the one.
It always returns where the address begins. It knows longs is 64 bits. So it knows from 1032 to 1095 is what I'm going to use. And they're not really blocks, it's a contiguous amount of memory. You put it like this to make it easier to read, but in reality it's just like this gigantic string of bits. Boolean is only 1 bit, right? Boolean means true or false. So true and false is 0. If it's not 0, it's true. Doesn't matter if it's 1 bit or 100 bits. The computer is going to allocate, for instance, so I'm going to have a variable to indicate if it's a leap year or not, whatever. So this one only needs 1 bit, right? I only allocate 32 bits at a time. So it's gonna, unless I declare multiple booleans, that it can put them together. It's gonna look like this. And so this one gets replaced by the address. So before you can use a variable, it must exist in memory. And the computer reads top to bottom, which means you need to declare them before you can use them. Okay? So if I declare them here, I can say and every time I do statements in C, I gotta say where the statement ends, and I have to use semicolon or end of instruction, whatever you want to call it. In math, you could do this too, right? It doesn't matter. But the computer does care where you put it. The computer says, this is the equal sign. And what do we call the equal sign? It's the assignment operator. So whenever it sees the equal sign, it's going to execute whatever's on the right side first in a CPU cycle. And it's going to put it somewhere in a register in the CPU. And then it's going to see the equal sign. By the time it gets to the equal sign, it doesn't know how it got the result, just has the result, because it's a separate CPU cycle. And it's going to put it on the left side of the equal sign. So if you have an equal sign, an assignment operator, what's on the left better be a variable. You cannot put h equals 32 because 32 is not a variable. It's a constant. So what the computer does, it says, remember it replaces the variable name with the address. Right? So it's gonna say, I got this value 32, put it in address 1000. So I was gonna put the binary of 1000 here. Oh, 32, I'm sorry, in here. I could say, you know, student I don't know, so I put an expression 1000 times 65. So a CPU cycle does this first, it comes up with a result, which is 65,000, and then it sees the equal sign, and then sees that this doesn't see the name of the variable, it sees the address of the variable. And it's going to go store that value, the result, in here. Follow me? I'm jumping a little bit for the next chapter because I want you to understand the syntax before we open C. Any questions here? Yes?
I'm sorry, where did you get the 65,000?
I put an expression here.
Is it just, you could put anything, or?
Well, it's a number times another number, and the long is a 64-bit number.
Where did you get those specific numbers?
Oh, I just came up with this.
Oh, okay.
So, characters a character, a single character, you must use single quotes to indicate the character. Technically, I could declare a variable int with one letter, right? I. So, if I say I, the computer is going to think it's a variable. to say, no, this is a character, or there's not grade I. So let's say you're an awesome student and you got an A, right? You gotta use single quotes to indicate, and of course you need semicolon at the end. So the computer is gonna go to address 1096, and guess what it's gonna store here? 65. Because the computer only cares about numbers, right? It's just binary. So the ASCII code of the letter A is 65. You can go to Did I tell you that last time?
Yeah.
Now, leap year. Let's say the leap year is true. So there can only be two values, right? True or false. So I'm gonna use true and always have the end of statement. And it's going to store 1 bit. Turn it on. It's true. You follow me? Questions? Easy, right? Just gotta think a little bit different. So, I said earlier, you need to have a point of entry. And what the compiler is looking for is for a main function. So, let me erase this. So all this needs to be inside a function. And the difference between a function and a variable is that the function, they kind of look the same, except the functions, instead of semicolon at the end, it has parentheses. So I need a function, a main function that returns an integer. So this is a function called main, which is like a variable, it's int, and it has parentheses. And because it's a function, I need to say this is where it starts, my curly bracket, and this is where it ends. So I need to have a closing, opening and closing curly brackets. So the rule is pretty similar. Function type instead of variable type is function type, isn't it? And then function name. Same rule, has to start with a letter or underscore, followed by letter and numbers or underscores, no other characters. And then you have parentheses. Parentheses could have stuff in here. We're going to talk about those later. For now, we just leave them close and open, open and close. So, this type, which is the same as the variable type, I told you was a function type. Actually, it's a return type. That means the function returns something. It's like when you have your calculator, put a number and press that button that says square root. There's a function called square root that's going to go calculate it. That's going to give you the answer back. Just give you one result. Right? So that type that returns, square root will be a double actually. I didn't put doubles, so decimals. We'll talk about those next week. So if this function returns an integer, at what point does it return that integer. So for now, in the main function, we're just gonna write the keyword return at the end before the closing curly brackets, and we're gonna say 0. So in our main, for now, we're just gonna say return 0 at the end. The reason is the program is launched by the operating system, right? So the operating system starts the program, and when the program closes, the operating system wants to know if the program closed okay or not. So if you return 0, there's no errors. If you return other than 0, the operating system is going to think, oh, that's an error number, which it's beyond this course to tell you how that, what the operating system can do with that. So for now, just do 0, okay?
Okay.
Any questions? Yes?
What happens if you set main to as long instead of integer, and you're running on a 32-bit like system? Would the program run or no?
Yeah, it will run, because you still return 0. That's you. I don't think you're gonna have more than 4 billion error codes. You know, we're gonna talk about casting later. We're gonna see how that works. When for instance, long here, obviously it's less than 4 billion, right? The answer. So it has 2 chunks of 32 bits. So one chunk is just zeros, and the other chunk has the actual number. So you can go from 64-bit to 32-bit as long as you don't have a value greater than 4 billion.
Okay.
Now if it's the other way, then you have a problem, because now you have more bits that you can fit, and that's called an overflow.